Pre-AP Precalculus, free response practice number 45, you cannot use a calculator. Let f of theta equal sine of 2 theta and g of theta equal cotangent of theta times the difference of 1 and cosine of 2 theta. Use the function to answer the following questions. Functions. For what exact values of theta is f of theta equal to sine of theta? On the interval from pi over 2 to pi, that's in quadrant 2, show your work. So it's asking, when is sine of 2 theta equivalent to sine of theta? Sine of 2 theta is the double angle identity, 2 sine of theta cosine of theta. If I were to subtract sine of theta from both sides, I would get 2 sine of theta cosine of theta minus sine of theta equals 0. If I GCF a sine of theta out of these two terms, I get this factored version of the problem. If I set each factor equal to 0, I'm going to get sine of theta equals 0. And I'm going to get 2 cosine of theta minus 1 equals 0. Solving this first equation, I get theta is sine inverse of 0. When is sine equivalent to 0? That's on the positive and negative x-axis. The positive x-axis is not in the domain. The domain is from pi over 2 to pi. So theta only equals pi in this case. Solving the second equation, I'm going to get 2 times cosine of theta is 1. Cosine of theta is a half. Cosine of theta is a half positive in quadrants 1 and 4. Therefore, cosine inverse of a half is undefined in the domain that we are given. There is no theta value where cosine is going to be positive in quadrant 2. So that's undefined for that. So our answer for this is just pi. Part B, for what exact value is of theta is 2 times f of theta equal to the negative square root of 3? Well, f of theta, it says above, is sine of 2 theta. If we were to divide both sides by 2, we would get sine of 2 theta is negative square root of 3 over 2, which means that 2 theta is equal to sine inverse of square root of 3 over 2. This is in one complete revolution around the unit circle. Square root of 3 over 2 for the y value happens in quadrants 1 and 2. So 2 theta is going to equal let's see here. I'm sorry, this is negative. This was a negative, negative, still negative. So that means that's going to happen in quadrants 3 and 4. Just make a quick drawing of that. If you don't need to make this drawing to do this right, don't. I need to. If the y value here is negative square root of 3 over 2, that makes this reference angle pi over 3. So it makes this angle 4 pi over 3. And it makes this one 5 pi over 3. Well, to get theta by itself, we divide both sides by 2, same as multiplying by a half. And we're going to get 4 pi over 6, which is the same as 2 pi over 3. I'm sorry, yes, 2 pi over 3. And 5 pi over 6. Then we need to add pi to each of these answers to find the other answers. So 2 pi over 3 plus 5 is going to be 5 pi over 3. Five pi over 6 plus pi is going to be 11 pi over 6. So we get these 4 answers. Lovely. Part C, use trig identities. Analytically show that f of theta equals g of theta for all values of theta. Well, let's see. F of theta was sine of 2 theta, and g of theta above says that that's cotangent of theta times 1 minus cosine of 2 theta. All right, well, I'm going to work with both sides here just a bit. This left side could be more easily, well, more complicatedly written, but more recognizable as 2 times sine of theta cosine of theta. The right side, I'm going to change cotangent to cosine over sine, and I'm going to change cosine of 2 theta into cosine squared of theta minus sine squared of theta. That is the double angle identity for cosine. Then I am going to distribute this minus. It's going to make this cosine of theta over sine of theta times 1 minus cosine squared of theta minus sine squared of theta. Then, I'm sorry, that makes that plus, not minus. Distributing this minus makes that a plus. This is the same as sine squared of theta. Now we got 2 of those. So that's cosine of theta times sine of theta times 2 sine squared of theta. We cancel a sine from the top and bottom. That makes this 2 sine of theta cosine of theta, and that's what we had for this left side after the first step. So finished. Excellent.